Hi guys, welcome back to my channel Pirai Academy. Today we are going to see about an important question called search in rotated sorted array. So it is lead for question number 33 and it is frequent question that is asked in Turing interviews. Okay, fine. There is an integer array nums sorted in ascending order with distinct value. So there are no same values. Okay, that's the first note you want to take. Okay, now prior to being passed to your function, nums is possibly left rotated at an unknown index k, okay, such that the resulting array is something like this. I will be telling you how. Fine. For example, if this is the sorted array, okay, if I just it might be left rotated by 3 in this, then become, if I rotate it in a left for 3 indices, then it becomes like the 0 1 2, these all gone to the right hand side. Can you understand this? Okay, given the array nums after the possible rotation and an integer target, return the index of the target if it is in the nums, or return -1 if it is not in the nums. Your algorithm should be of O of log n. We can just go and watch, then we can come back and let us write the efficient algorithm. Okay, fine. So see here, if this is the rotated sorted array and this is the target, then I will be returning 4. If this is the rotated sorted array and target is 3, 3 is not present, so I will be returning -1. Fine. So let us go with the logic. First of all, whenever we are going, we will be taking a brute force approach. What is a brute force approach? It is so simple. I will be just traversing. So do a linear search. Just to go and search. That's it. So do a linear search. So 4 is not equal to 0, 5 is not equal to 0, 6 no, 7 no, 0. 0 is equal to 0. So what is the index? It is 4. So 4 should be my answer. So this is going to be a brute force approach, and time complexity will be O of n, because you will be searching all elements in the worst time complexity, and your space complexity will be O of 1. Okay, now let us go and optimize this. Okay, how we can optimize it? First of all, what they have given? They have given it is rotated sorted array. Rotated sorted array, which means it is already sorted, but it is just rotated. Okay, which means anyhow at every point the previous element will be always less than the next element except only one point. For example, see this example here. Up to this they are sorted, and up to this they are sorted. At this particular point only it is not sorted. So from this itself I can tell you that we are going to just check whether it can be solvable by using a binary search approach. By using this binary search approach, you will be ending up with O of log n if it is successful. If it is not successful, then we can go with any other approach, or we can better take this approach itself. Okay, now let us go with this binary search approach, and mainly in your interview point of view, they will be not giving you the expected time complexity. You have to find out it. Okay, for example, if they exist 10 power 6 or 10 power 6 greater than 6 or 10 power 5, okay, then n square is not allowed. Can you understand this? Yes. If the given length is 10 power 9, then n only solvable, not n log n, because the clock time is 10 power 9. Okay, so it is somewhat important. I will be giving you a separate video for algorithm basics. Okay, now as of now, let us go and check whether binary search can build a logic for this approach. Fine. So initially I'll be taking a lower pointer here, I'll be taking a upper pointer here. Always for binary search we will be having a lower limit and upper limit. Now tell me, what is the mid formula? To find the mid, it will be L plus U minus L divided by 2. This division is only for this particular bracket, okay, not for this L. Okay, fine. So for example, if for this I want to find the midpoint, then 0 plus 6 minus 0 divided by 2, which is equal to 3. Can you understand this? We can also put L plus U divided by 2 formula, but at your utmost integer, it will be overflowing. That's why we are going with this formula. Okay, that's the reason why I am going with this formula. Fine. Now what is the midpoint? Midpoint is 7. Okay, what is our target element? Target element is 0. Okay, now mid is here. Now what is the relationship between my mid and my target? My mid is 7 while my target is 0. So 7 is greater than 0. Yes, yes, which means in your basic sorted array, where the 0 will be lying for the 7, it will be lying in the left side, right? For example, see here 0, 1, 2, 3, 4, 5, 6, 7. In this scenario, for this 7, where is my 0? My 0 is in the left hand side. Can you understand this? So as of now, we will be going and targeting this left hand side elements. Can you understand this? Okay. How we can know whether this left hand side element surely have this element 0? How we can know? Okay, let me just take it. How we can know this? See here, what is the L value? It is 4. What is the mid value? It is 7. Okay, which means between this, there is no possibility of having a 0. Can you understand this? There is no possibility of having 0. So from this, I can clearly state going to this part of this half array is useless. We can go to the next part. So if I want to go to the next part, it will be L is equal to mid plus 1. Can you understand this? Why I am going here? Because going and traversing to these parts is unnecessary. Can you understand this? Yes. Okay. Now what is the midpoint? Midpoint will be 1. Now again, tell me where my 0 will be present. 1 is greater than 0. Again, I want to search in the left hand side. Okay, search in the left hand side. What is the L? It is 0. Okay, 0 is equal to 0. Which means, yeah, the 0 is present in the left hand side. So shrink your upper limit to mid minus 1. So upper limit here. Now where my mid faces? My mid is facing to 0. Can you understand this? So 0 is present at the fourth index. Now 4 will be written. The mid value will be written. That's it. Can you understand this? By doing this approach, my time complexity will be reduced to over log n, because since it is already sorted and rotated, and my space complexity is over 1. Can you understand this? Yes. So how my code is looking like? We will be having two conditions, like if my mid value is greater than my target value. Okay, then what should I do? I should be going to the left side. Okay, I'm going to go to the left side. Again, inside that, again, another if condition. What that if condition is telling me? If the target value is in between my left hand side. Okay, then only I want to move to the left side. Left side means what? What is the meaning? Which means u is equal to mid minus 1. Else I want to move to right side, which means L is equal to mid plus 1. Can you understand this? If this is not the case, then what should we do? We should be just checking whether it is in the range of mid to the upper limit, because now the mid is less than target. Okay, which means, see here, if mid is 7 but my target is 10 will be appeared in the right hand side, right? So first of all, I want to check whether it is in the range. So whether it is, the target is greater than my mid, okay, and it should be less than my upper limit. If this is the condition, then you can surely go there. Can you understand this? If this is not the case, then where should I go? Should be just going to the left hand side. Can you understand this? In between this, here comes if. This is elif or else if. So if my mid value is equal to my target, then what should I do? I should be just returning it. That's it. Returning the mid value. So here that doesn't come equal to, and here also doesn't come equal to, because the target value cannot be equal to the mid value if this condition is executed successfully. That's it. So this is going to be your overall code. Let me show you the code so that it will be more clear. Linear search code you can try by yourself. I'm going to focus on the binary search code. So see here, first of all, I am assigning a lower limit and the upper limit. Now while my lower limit is less than or equal to the upper limit, why I am putting here? Because see here, if there is an array, let me draw here. If there is an array of 1, 2, 3, 4, 5, take for example, if here is a upper limit and then here is a lower limit, whether this is a valid? Yes. If here is the lower limit and here is the upper limit, whether, sorry, here is your upper limit and here is your lower limit, whether it is a valid? No, because always my lower limit should be less than or equal to my upper limit. If it is not the case, then I can tell you that there is no element that is equal to target. That's the basics of the binary search, right? So that's why I'm just going up to what? L is less than or equal to U. Now inside that, I'm just taking a mid formula. In Python, you can take like this. Okay, in Turing, you will be just coding in Python. But if you are going for any other languages, you will be using the formula like L plus U minus L divided by 2. Okay, now here comes, if the mid value is equal to the target, then I'll be returning the mid. Or else, I want to check whether my L is less than my mid. If it is so, then I want to just check whether the target is in the range of my lower limit and the mid. If it is so, then I will be going to the left side. If not, I will be going to the right side. Okay. Similarly, in the else condition, if my mid is my target is in the range of mid to the upper limit, then I'll be just going to the right hand side. If not, I will be going to the left hand side. After finishing this entire loop, still there is no return value, then after that my -1 will be returned, which means there is no element as the target. So this is your overall code. If you really like this video and subscribe to my channel. Don't skip any videos in this playlist, because all videos will be helpful once you are appearing for the interviews. And if you want to know about these kinds of algorithms, just go and search in my YouTube channel. And specifically, if you want to know about the binary search, go and watch my binary search playlist. Thank you.